This video is for Integrated Math 3 students at Sturts Creek High School. We're going to be going over the Unit 5 study guide, which is coordinate geometry. We're going to go through every question on here. Hopefully it's helpful in preparation for our test that's upcoming. In the study guide, the first thing that you're going to want to do is change a few numbers. We wanted to adapt a couple of these. The first thing is this. I'm going to zoom in on questions 1 through 4 here. Let's change this ratio here. It says 3/4. Let's change that to 2/3. And then the second change is going to be this. This k is going to change to -1, -2. And then lastly, we want to change this ratio of 2 to 7 to 2 to 4. Okay, so those are the main changes. We're going to go ahead and get started. What you need to do is, and what I find most helpful with these first 4 questions, is to have some sort of graphing paper to plot these on. So we're going to look at this first question. It is, it says find the coordinates of the point P that is 2/3 of the way along the directed line segment from C to D. So I'm going to go ahead and plot C right here. D is right there. And to help with this, we're going to connect these points with a segment. So from here to here. And we need to talk about what this means, 2/3 of the way. That means if I split this into thirds from C to D, because that's the lines that we're looking at, C to D. So from here to here, I need to go 2/3 of the way. So the first thing that we want to do is we want to split this into thirds. So I'm going to write that. So split the line into thirds. The best way to go about this is to draw a few more lines. So first off, I want to relate this to slopes. I'm going to go here to here. We're going to make a triangle. I also want to change the color of these. Oops. Let me undo that. I want to change the color of these to talk about rise and run. So right here, this is going to be the rise. This is going to be the run. So those are our lines. Now, if we count, we go up how far? Well, it goes up 9. So I'm going to write that up here. Up 9. And then it goes back how far? Well, that is from 6 to -3. So back 9. Okay, and what we want to do is we want to split these segments into thirds, essentially. Since we want to go 2/3, we're going to divide these by 3. So for every partition on our black line here, we're going to go up 3, back 3. So this is up 3 and back 3 when I divide this into 3 parts. To show this, I'm going to put points. So I'll go 1, 2, 3. There's a point there. 1, 2, 3. Now this one's broken into 3 segments. Let's go back 3 every time on the blue line. 1, 2, 3. 1, 2, 3. Yeah, well, that was 2. 1, 2, 3, right there. So there's 3 sections there. Where these points intersect are going to be the segments on our line. I'm going to put those here and here. So now I have 3 parts. So the point P, that's going to be 2/3 of the way along the directed line from C to D. Well, if I go, here's 1/3, here's 2/3. Let me change the name of this to P, like it's asking. And this is going to be our point. The coordinates for it are 0, 1. So the answer, P, is 0, 1. And that's what we want for our answer here. All right. Similarly, let me get rid of all this. We're going to do the next question, which is RS. So we want to find the coordinates of point Q, that is 2/3 of the way along the directed line segment. So this is just like the last one, 2/3 of the way. We need to find our change here. Is it the vertical change and the horizontal change? And we need to split it into thirds, just like this last question. So I'm going to put R and S on here. We put S. So there's S. And let's scoot to where we can see this. There it is. There's R. Okay. I'm going to connect these with the line. So from R to S. And then I'm going to go ahead and do the exact same thing I did. We want to split the line into thirds, just like the last one, 2/3. So let's see what our changes are going up to right here, over to here. Keep doing that. Let's change the colors of these. This is going to be my green. This will be my blue. So we can see that the change here is 1, 2, 3, 4, 5. It goes up 6. So up 6. And again, we're going to divide that by 3. That gives us 2. So we're going up 2 every time. And then we're going right 1, 2, 3, 4, 5, 6, 7, 8. We have to go right to 9. So right 9, which we're going to divide by 3. That gives us 3. So I'm going to go ahead and plot points on here. I'm going to go up to every 2, 1, 2, 1, 2. There's 3 parts. Then I'm going to go to the right 3, 1, 2, 3, and 1, 2, 3. Where these intersect, I'm going to place those. So BF is right here. That's the intersection. EG, oh, missed it. EG is right here. So we have this black line is now split into thirds. Going from RS, I want to go 2/3 of the way up. So 1/3, 2/3. This is the point that I'm going to name Q. Okay, and that is -1, 2. So our answer for Q is -1, 2. There it is. So that one's answered. Let's go to the next problem. So back to these points, we're looking at JK. So from J, which I can't see, where's that at? It's +10. So let's go here to there. So there's our line that we're going to have to create from J to K. We have the ratio of 2 to 4. Now that's different than what we have up here. When we say 2/3 of the way, that means we need to split it into thirds and go 2 of them. Now, when we say we want to split the segment, partition the segment into the ratio of 2 to 4, that means that we need to split it up into 6 parts. And when I compare the parts, the ratio is 2 to 4 parts. So that's the key thing. When you see a ratio, you have the total parts. You want to combine those to make 6 parts. So let's go ahead and draw this line. So we're going from J to K. And I'm going to go ahead and construct the vertical change to the horizontal change. And let's change the colors of these lines. We'll make this one green, this one blue. And you'll see this one goes up 3. So up 3. And then over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's the change there. Let me double check that. From 10 to, yes, so that's 11. So back 11. Okay, so since we want to break this into 6 parts, it means I've got to divide by 6 for both of these. Okay, so on this one, I get 1/2. So I'm going a half up every single time. So we're going to see what that looks like here in a second. And then back 11/6. Let me make sure I've got that absolutely correct. -1. Okay, yep. That's what we have. So 11/6. Well, what is that ratio? That's 1 something. It's almost exactly 2. 11 divided by 6 is 1.83. Let's turn that into a fraction. 11 divided by 6. Oops. Make it a decimal. Let me take away 1 and approximate that to a fraction. Make that a fraction. So 5/6. So it's 1 5/6 of the way on that one. So this one's a little more challenging because of these fractions, but we're going to do our best to get this partitioned. So that's the ratio we have. Let's go ahead and give this a shot. So I want to find the halfway point. We're going to go up a half every single time since we're breaking this into 6 parts. It'd be nice if I could find the halfway point. So yeah, right here, this is the halfway point. So I'm going to go from J up to the halfway, 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 halfway. Let me move this, halfway. So we split it 1, 2, 3, 4, 5, 6 parts. Okay. And then this is going to be a little more challenging to do. We have to go every 1 and 5/6 of the way. So we're going to give it our best shot here. We're going to go over, here's 1. I'm using this scale up here, by the way. So this is back 1, 1.5, and then I need to go 2/6 of the way. And this is kind of challenging because it's broken into fifths. So that's a little bit difficult, but I would say probably about right here. Seems okay. And we'll just keep splitting this. The best way to do this, I'm going to go ahead and say this, would be to go up on this halfway point right here. And we know that we're going to go a 2-to-4 ratio. So if I go up 1, 2, this line here where they intersect right there, that should be the point that we want. Okay, because they are, just like we saw in the other two, they're going to intersect on the line there. So this should be our point. Let's go ahead and analyze this point here. Let me change the label. We say that this is going to be point R. Okay, and I'm going to go to my tool over here, and we have this point R. Where's that at? Well, I already named one R. Let's actually name it Z, just so that I can see it on here. And maybe I can get the, okay, so here's our point. It's -6.3, comma, we'll just say that's -4. So that's what I'm going to go with, 6.3. We're going to say R will be 6.3, comma, -4. And we'll say that that's going to be our answer for this. It's unfortunate that we had such a nasty fraction to deal with. That does complicate things. But really, with the halves, that's what we use to help us with that. Since I could easily split this up, I know that that intersection point is going to be where that value is going to be where we want to go. That is 2 to 4. And I'm going to zoom out a little bit just to show the comparison. That this length here, if I took this and divided it by this length, the ratio would be 2 lengths to 4 lengths here. So this is 4 times the length of this right here. Alrighty, I'm going to undo all that. We'll go back to our original here, get rid of that. Okay, and let's go to the next question. We're going to have the coordinates. We're going from M to N. So right here, and what's nice about this one is it is a straight line, just vertical. So from here to here. There it is. Okay, so we have another ratio. We want to partition the segment. We want to draw the point P that partitions this segment into the ratio 4 to 6. So from that last part, we know that this means it needs to be split into 10 parts. Since this is going one direction, we're just counting how far this goes. Well, the point, it goes from -2y to +8y, so the distance is 10. So all we have is up 10. It doesn't change in the horizontal direction. So if I want to break it into 10 parts, I'm going to divide that by 10. That means we're going to actually go up 1 every single time. So I'm going to have a lot of points on this line. Here, 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 here. Every one, I'm going up, and that breaks it into 10 equally sized parts. Now, we want to put the point P where the segment ratio is 4:6. So I'm going to go up 4 parts. Here's 1, 2, 3, 4. This point right here is what we need. This is going to be that point P. Okay, that's our point P right here. The coordinates for it, -5, 2. So P is -5, 2. We got it. So it definitely helps to have graph paper on these, and you can draw yourself a coordinate plane for this. You can just do a simple one of these and draw them out as you need to and approximate the points. It does help, of course, to have some graph paper handy to do those. Let's move on to the next couple questions. This time I'm just going to be using the sheet. It says parallel, perpendicular, or neither. This is the second section. So we have 2 lines. We have A, B, and C, D for all these parts. What we need are the slopes of these. Parallel means they have the same slope for parallel. Perpendicular means you have opposite reciprocals. That's what that is. And neither means it's neither of these. Okay. To find slope, we have this formula. You want y2 minus y1 over x2 minus x1. What I like to do for these is I like to go ahead and label them. First, we're going to start with the slope of AB. So I'm considering these points here. We're going to consider our second point to be B. So I like to do this. I like to put a 2 here and a 2 here, a 1 here, and a 1 here. Okay? Just so it keeps it straight. So for AB, I'm going to say slope of AB is going to equal y2 minus y1. So that's 4 minus 5. And then that's over x2 minus x1. So that's -8 minus, that's a -11. Now I just do the operations. 4 minus 5 is -1. -8 minus -11. So we can do a change here. These become addition. So it's -8 plus 11 essentially. So that's over 3. So -1/3. Now that's how you calculate slope. And we're just going to do that for all of these. And we're going to compare them to figure out what we want. So slope of AB is -1 divided by 3. Slope of CD is, I'm going to do the same thing here. Let me change my color to green on this one. This is 2, 2, 1, and 1. So y2, -4. Y1, minus -7. X2, -1, minus 8, which is x1. We'll do this. I'm going to do the change here. So this is going to be 3 on the top. -1 minus -8, that gives me -9. All right. So when I simplify this, I get 1 over -3, which is the exact same thing as just saying -1/3. So that's this slope. So our answer to this, what type of lines are they? Are they parallel, perpendicular, or neither? Well, they have the exact same slope. So we're going to say parallel. We're going to practice that those same operations on number 20 and 21. So let's go ahead and start doing that. I'm going to do blue for this first one. So this is 2, 2, 1, 1. And we're going to say for AB, we have 15 minus 8, 1 minus -3. All of this comes from this formula up here, the slope formula. So this gets me 7 over, these change to pluses, 7 over 4. So that's my first slope. Change to the green. So this is CD. I'm going to say this is 2, 2, 1, 1. So this is y2, -5, minus -9 over x2 minus x1. So that's 3 minus 10. This changes signs, and we get -5 plus 9 is 4. 3 minus 10 is -7. So that, which I can simplify to -4 over 7. So we compare these slopes, and these are opposite reciprocals. Reciprocal means to flip. Opposite means change sign. As you can see, we have flipped the numbers. It was 7/4, it became 4/7. We also changed it to the negative sign, so these lines are perpendicular. All right, on to the next one. We're going to do AB. This is my second point. This is my first point. So this will be 4 minus -3 over 9 minus 9. Yep, 9 minus 9. All right, and what we get here, we'll do the change. We're going to get 7 over 0. So whenever you have a 0 on the bottom, that is undefined. That means this is a straight, a vertical straight line. If I were to draw it, it goes up and down. Okay, so we don't actually get a slope here. So we're going to say no slope. So what I'm looking for here is this one is going to be, and actually let me change that to undefined. We'll actually write that in here when it goes straight up and down. Let's see what we get. There is a possibility that this will be perpendicular, or it could be parallel. Perpendicular would be 0 in this case, and then of course parallel would be also undefined. But let's just see what we get here when we do CD. So these are my two second point, first points. We're going to do 6 minus 10, and then we get -2 minus -2. So this is going to get us -4 over, this is 0. So again, this is undefined. You can't divide by 0. But that does mean, even though we can't define the slopes, that means that this one is also going straight up and down. That means that they are going to be parallel lines. So just because we can't find the exact slope, if they are both undefined, that means that they're going to run side by side. They're parallel on our graph. On to the next page. We're looking at determining if the line's parallel, perpendicular, or neither. So the same rules apply. We have to show that the slopes are the same for parallel, opposite reciprocals for perpendicular. And if they don't have either of these situations, then it will be neither. So as we look at these, the most important thing to do is to get them into y equals mx plus b. And then what we're looking for is this. This is our slope. That m value is the slope. As you can see, none of these are in that form. How we do this, just use some algebra. Just get it into y equals. So the first thing I'm going to do, minus 6x. This becomes 10y equals -6x plus 20. Then we're going to divide both sides by 10. This becomes y. And I'm going to divide each one of these. I'm going to break it apart into two fractions. I'm going to split that over the 10. I'm going to zoom in a little bit so I have plenty of space here to do my work. So this is going to become, when I simplify it, this is going to be -6 over 10 is going to reduce to -3 over 5x. This is just going to become 2, so plus 2. We're going to do the same algebra steps over here. I want to subtract 5x, do the inverse operations here to solve for y. Then I want to divide by -3 on both sides. I'm going to skip that step where I broke this apart, and I want y'all to just go ahead and understand that that's what's happening, is we're splitting it apart. This becomes -5 divided by -3. Those negatives go away. I get 5 over 3x. 21, positive 21 divided by -3 is going to be -7. So what I'm interested in are these. right here, and right here. So you'll see that we flip it and change the sign. So these are perpendicular. And that's how you're going to interpret those. That's what you're looking for. You're just going to find the slope. So let's go ahead and go through algebra on this. I'm just going to be working these problems out. I'll have a few comments here and there about different things, but I'm just really going to go through and work all this algebra. Here I've got this negative can't be here. It has to be positive y. So we're dividing by -1 to change that sign. So this gets me y equals, these negatives go away, so it's just x. This will change the sign, -4. So there's that one. Over here, we're going to subtract x from both sides, and I don't have to do anything else with with this y because it's already positive, so it's -x plus 9. And we have to think about these slopes. Well, this one was positive, this one's negative. We don't really see the reciprocal. Over here, it was pretty obvious that this flipped. But if you think about this as 1 over 1, and this as -1 over 1, you're sort of flipping them in a way that you can imagine them being flipped, but the ones just, they just flip and you can't really see it. But it did change signs. So we are going to conclude that these are also perpendicular. Let's move on to 24, and we'll continue with the same algebra. Put that in half. We're going to subtract x. It's us -5y. Don't forget the negative. That's very important. -x plus 30. Divide by -5. Goes away. We get y equals. These negatives go away, but it is x over 5. There is a 1 in front of this, so we're going to do this. 1/5 x. The positive and negative becomes -6, so there's our equation. Let's do this over here. You can see they already have the x on this side, so all I got to do is divide by 10. This is going to go away. I get y equals 2 divided by 10 simplifies to 1/5 x. 90 over 10 is 9. We look at these right here. We can see that they're the same, so that means parallel. Whoops. I need an eraser on this. Screw that out. It's parallel. Okay. Let's look at this. X equals 5 and x equals -2. So what that is vertical lines. So if I were to draw a graph, this is 1, 2, this is -2. This is 1, 2, 3, 4, 5. This is 5. These lines are going straight up and down through here. This is sort of like that undefined slope. So these would be parallel. There we go. All right. So now we need to write equations. We're on 26 now, new section of this. Write a linear equation that passes through the point -6, 1 with a slope of y, or excuse me, of 1/2. So this all is going to revolve around this formula, y equals mx plus b. The slope is going to be m. So I'm going to go ahead and start the equation by just writing this in. Y equals 1/2 m plus b. I'm sorry, this needs to be x. Let me start that over. Y equals 1/2 x plus b. To find b, to get our final answer, we have to solve for b. And how we do that is we plug in this x and this y. So this is going to be y is 1/2 times this -6 plus b. We're going to multiply these. That gets us -3 plus b. And then I just want to add this 3 to both sides. And that gets us 4 equals b. So to write our final equation here, we get y equals, well, the slope is 1/2. x plus that b value that we solved for. So here's our answer to this question. Next, write a linear equation that passes through the points 3, 1 and negative 2, 6. Now this time it doesn't give us our slope. So what we need to do, the strategy in this one is to actually solve for the slope. We did this on the other page. We have to use the slope formula. That's slope equals y2 minus y1 over x2 minus x1. So I'm going to label my points. Let's get the slope. That's going to be 6 minus 1 and negative 2 minus 3. That's going to get us 7 over, this is going to be negative 2 minus 3, which is negative 5. I made a mistake with this. This should be a 5. 5 over negative 5. So that is negative 1. So this is our slope here, negative 1. Okay. So with the slope of negative 1, we're going to put it into the y equals mx plus b. So y equals m, which we just said is negative 1, x plus b. Just like we did over here, we need to solve for this b value. So I'm just going to plug in, we know it goes through these points, so let's plug in a 3 and a 1. Those seem the simplest. So it's 1 equals negative 1 times 3 plus b. This is going to give us negative 3 plus b, and then we're just going to add this 3 to both sides. That gives us 4 equals b. We had that last time, except our slope is different this time, but we have all the pieces we need. We're going to say this is our equation, y equals m, which is negative 1, x plus 4, which is our b value. So here's our answer to this question. Okie doke. Let's move on to 28. So we need to write an equation that is parallel to y equals 3x plus 5. It has to pass through the point negative 4, negative 13. So just like we did on the last two questions, we're trying to build an equation. We first need to find the slope for parallel. Parallel lines have to have equal slopes. So we're going to start with that. The slope of our new line should equal 3. Okay? So I'm going to write that up. Y equals, and we're going to say 3 because that's the slope, x plus, we're not going to use this value. We're trying to make a new line. If I use 5, I've just created the new line and there's no work to do. But we're trying to make a new equation that goes through this point here. So we're going to take these points. This is x, this is y. We're going to plug them in and we're going to solve for b like we've been doing. So this is negative 13. I wish this had an eraser. Where is that? Let me start over. All right, negative 13 is equal to 3x plus, not 3x. Start over one more time. Here we go. We got it this time. Negative 13 equals 3 times negative 4 plus b. Now we're going to do the algebra and solve this. This is negative 13 equals 3 times negative 4 is negative 12 plus b. We're going to add this 12 to both sides. That gets us negative 1 equals b. And our final equation with this slope 3 and this b value of negative 1 is going to be y equals 3 x minus 1. There's our answer. So the b value goes here. The 3 comes from the slope. All right, 2 more on this page. Write an equation that is perpendicular to y equals negative 4x minus 6 and passes through the point of 4, 10. Let me change the color. Let's do orange. Okay, so let's talk about slope. The slope right now is negative 4. And if it wanted parallel, that would be fine. But we need to make a perpendicular slope. The perpendicular slope is the opposite reciprocal that we talked about on the last page, which means we need to flip this and change the sign. We know the sign's negative, so this should be positive. But what are we talking about when we say flip it? Well, it's just a 4. How do we flip a 4? Well, if we made this into a fraction, it would be 4 over 1. So that means that our slope will be 1 over 4. This is the slope we need to use. So let's go ahead and set up our equation. Y equals 1/4 x plus b. We don't want to use the same b value. To solve for b, we plug in these points. The y value is 10, and the x value is going to be 4. When I multiply 1/4 of 4, when you multiply those, these 4's actually go away, and it just leaves you with a 1. And the 10's over here. I'm just going to subtract this 1. These go away. 10 minus 1, that's going to be 9 equals b. So my final answer, y equals, we want to use the perpendicular slope, 1/4 x, and this b value that we saw for, plus 9. So there's our answer. Right on. Let's go to 30. Perpendicular again, and on this one, it's not already in the slope-intercept form that we need. So we need to, like we did at the very top of this page, we need to solve for the slope. That is right here. We had to do algebra to solve for all of these. So we're going to do that on number 30 here. We want to get it into its slope-intercept form first. So I'm going to manipulate this. We're going to take away the 2x, so minus 2x. It gets us negative 5y equals negative 2x plus 5. Let's divide away this negative 5 from both sides. This goes away. Here's the actual slope-intercept form that we want. These negatives go away, and it's just 2 over 5x. And 5 divided by negative 5 is negative 1. So here's our equation, and the slope that we get is right here. So this is our slope, is 2/5. However, perpendicular, we want to draw this perpendicular slope. The perpendicular slope is going to be the opposite reciprocal. So opposite has to be negative. Flip it, 5/2. So let's build this equation. Y equals negative 5/2 plus b. We plug in our x and our y over here. Those go in here to solve it. I forgot my x here, so the x is there. So this is negative 9 equals negative 5/2. X is 2 plus b. So these go away. We're left with negative 9 equals negative 5 plus b. We're going to add 5 to both sides. These go away. When we add these, we get negative 4 equals b. Writing our final equation over here, we get we're going to say y equals, we use our perpendicular slope for this, negative 5/2 x plus minus this 4 here, the negative b, or the b value, minus 4, and that's our answer. Okay, so that's how we're going to create lines parallel and perpendicular. This is one of the more important topics on this test. As you can see, we did a lot of examples with it. Very important that you know how to do that. Let's go to the next part. So this is classifying quadrilaterals in a coordinate plane. So this one does have quite a bit of work. We've got 4 questions that we're going to work here. And what our goal is to look at the sides, or if the sides are congruent and if the diagonals are congruent, okay? And it says use the distance formula, but we're going to be doing it using Pythagorean Theorem to solve these questions. The first thing that we want to do on this, I'm going to zoom out a little bit just so I can get plenty of space here to show this work. Let me zoom out just a little bit more. Okay. So we're going to plot these points, and if you have your own graph paper you want to do this on, that's fine. So we have negative 9, 14. So negative 9 is here, up to 14. So right here. That's going to be S. Then we're going to go to T, which is 1. Positive 1's here, up to 10. So right here. It's going to be T. Negative 3, 0, right here. And then negative 13, 4. Negative 13, 1, 2, 3, 4. This is U, and this is V. And I'm going to connect these with straight lines. Use red, that's fine. So from here to here, from here to here, from here to here, and one more. All right, so I'm going to go ahead and help myself out a little bit. The first thing that we want to do is find the side lengths. All right, and hopefully you should have some notes on how to classify each one of these. I'm going to be just saying them out loud. I don't have the sheet to show you on here, but you should have notes on how to classify these. Right now it does look like a square, could be a rhombus, but we have to prove it by finding these side lengths. So we need to find ST, TU, UV, and VS. Those are the sides that we want to find. All right, so we're going to talk about how to find each one of those. The first thing I'm going to do is I'm going to draw some lines going from S. This is the change in X value, and I'm going to draw a line down to T. And you're going to see that this goes over 1, 2, 3, 4, 5, 6, 7, 8, 9. That goes over 10 and down 1, 2, 3, 4. So that's the change. So to calculate our distance, we're going to do the Pythagorean theorem, which is a squared plus b squared equals c squared. This is going to be our c value here, this red line. That's how we're doing our distance. Distance formula is similar to this, but we're going to use just Pythagorean theorem because I think most people have that one memorized. 10 squared plus 4 squared equals c squared. If we wrote this up, this would be 100 plus 16, okay, which is going to equal 116, which equals c squared. All right, so this is 116 equals a c squared. To get our length, we're going to take the square root, and that's not a perfect square, so we're going to say that c equals 116. We're going to repeat this for the rest of them, and the good news about this, it does seem like it's a lot of work, but if these are exactly the same, then I already know the calculation. So I'm going to go down, see how far that is. It goes down to here and then to here. So the change here, it was at 10, so I already know that this is 10, and it goes from -1 to -3, so that's 4 again. So right away, I know that this is going to have a length of 116 after showing the square root of 116. I forgot to do that. So square root of 116 is our length, okay? So that one's going to be the same. Let's just check that with the others. This one goes over to -13, up to +4. Again, we're seeing that this is going 10 this way, 4 this way. Let me go ahead and draw the last one here. This goes up. Oops. It goes up and then over right there. And this goes from 4 to 14, so yeah, that's 10. And then from -13 to -9, so yeah, that's 4 as well. So all of these have the same exact sides. So I'm going to say all sides congruent. All sides are congruent. So that means that it could be a rhombus, it could be a square based on our definitions of those. Parallelograms have and rectangles have opposite sides congruent. Rhombuses and squares have all sides congruent. So it could be either of those. The last thing that we need to check to distinguish between those are the diagonals. So I'm going to draw the diagonals. Diagonals go from opposite vertexes, here and here. Okay. And we're going to calculate the lengths the exact same way that we did for the other ones. I'm going to use purple for this. So I go over and up. And we're going to see what what these links are. This goes up 1, 2, 3, 4, 5, 6. So up 6 and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Something that's going to be nice about this without doing as much work is if this diagonal does the exact same thing, then if it has the exact same links, then we know that they're congruent. If they're different, then they're not going to be congruent. It'll be a rhombus. So I don't really have to show too much work here for this one. So up and over. So let's count those and see what we get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this one is 14 as well. 1, 2, 3, 4, 5, 6. Okay, so that shows that these are also congruent. So diagonals are congruent. So the first thing that we wanted, all sides congruent, diagonals congruent. What this leads us to conclude is that this is in fact a square. So we're going to put that right there. Square. Let's graph this next one. I'll probably leave the last two open just to shorten the length of this video. These do take a little bit of work and take up a lot of time. I'll work this one and then I'm going to move on to the next section. Okay. All right, so let's go ahead and plot these points. I'm going to do points at -7, -4, so right here, 2, -3, 0, -7, and then -9 right here to -8. So -9, -8. Right here. Okay. Very important that you are very precise with these lines. Let me actually label those points first. So this is E, this is F, G, and H. So we're going to connect these. And as we're looking at it, it looks most like a parallelogram. Let's just prove it really quick. That's the whole point of this. So we're going to start with side lengths. So for the side lengths, we want EF, FG, GH, and HE. So we're going to try to solve for all of these. Hopefully you can tell that EF is not congruent to FG just by looking at it. We do need to prove it with the numbers, however. So I'm going to go ahead and draw up one over, we got to figure out how far that is. 1, 2, 3, 4, 6, 7, 8. It looks like 9 on there. I need to change to pencil. This is 9. This is 1 right there. So this is 1 squared plus 9 squared equals c squared. So this is going to be 1 plus 81 equals c squared, which is 82 equals c squared. When we square root both sides, square root of 82 is equal to c squared. I'm sorry, c. Let's start that over. So 82 equals c squared. Square root them. So square root of 82 equals c. So that's the length of this segment here, square root of 82. I can go ahead and say that looking at FG, it definitely has different dimensions, and we can see that as we count these. We go down 1, 2, 3, 4. We go over 2. So that is going to mean FG is 2 squared plus 4 squared equals c squared, which is 4 plus 16, which is 20. Square root that. We know that square root of 20 is C. Obviously not the same. Let's just look to see what happens with the rest of these sides. This is down 1 over, and that's going to be 1 and 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9. Let's grab the other side links. We go up, up and to the right. So this is 1, 2, 3, 4, and 2. So we can see that these opposite sides are going to be congruent. We know that this is going to be square root of 82. C equals square root of 82. And on this one, C equals square root of 20. So we're going to say, first off, opposite sides are congruent. Okay, let's look at these diagonals. I'm going to pick, I'll do purple again to show these. And we're going to go from E to G and F to H. Got a blue, so we're going over and then up. So this is over 9 and up 1 again. So the diagonal is the exact same length at, oh, sorry, I'm measuring the wrong thing. We need the purple lines. Let me get rid of these. Okay, purple lines, we're going over and down right there. Those lengths are, we have 1, 2, 3, 4, 5, 6, 7, and then down 1, 2, 3. So 7 and 3. Let's look at this one here. We're going up and to the right. And that distance, we're going 1, 2, 3, 4. That's 5. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 for that distance. So you can see that the diagonals are not congruent. So diagonals are not congruent. What that tells us is that this is a parallelogram. If it were a rectangle, these would be congruent. So this is a parallelogram. Okay. So the other two questions will work like that. Find the side links, see if they're opposite sides are congruent, or if all sides are congruent. That helps you determine if it's rectangle, parallelogram, rhombus, square. And then if the diagonals are congruent, it'll be a rectangle or a square. If they're not congruent, then it's a rhombus or a parallelogram, depending on what happened with the side links. So those are the other two questions there, which I'm going to skip for brevity. I'm going to pass this up first and go straight to these parts right here, the constructions. So for these, it's saying for these constructions questions, the arcs for a compass and a straight edge construction are shown below. What construction is being made? So on this one, we take a line segment, which I'm going to pull up a paper to show this. We take a line segment. And what we're doing is we're going to put points on the ends here, here, and here. And we take our compass and we put it at the end point here. And what they're doing is they're dragging it past the halfway point here. So if we go past halfway and they're starting right here, we're going to draw part of a circle. So down and also up. Okay. Then we are going to draw the exact same line over here, which I think this is too big. Let me actually undo this. I want a shorter line to show this. That's that line was too big. So let's do this one. So let me draw these points again, because that would not fit on my screen. All right, here's the compass again. Right there on the end point, go past halfway, and let's draw the circle, or half of a circle. Go over here, we're going to repeat that on this side, copy the same circle. Where they intersect, which is what we're seeing on this one, these intersection points, if I connect those with a straight line from here, oh, that's not perfect one right there, down through, it's going to intersect at a right angle. So right here is a right angle. It's also going to split this in half. So what we call that is a perpendicular bisector. So on this one, the answer that we want to pick is this, perpendicular bisector of MN. All right, so down here we have the construction. Eric constructed BD as shown. So that's this line. Which of the following statements must be true? Well, let's look at this construction. The first thing that happened, I'm going to draw this new page here. We have an angle. I'm going to draw just sort of a random angle, similar to what we see on there. And the first thing that happened was, from this point, we drew a circle through right here, and we're going to just draw a circle that goes through this. So we see looks similar to what had happened with Eric's construction. The next thing that happened is these two lines here. Those got drawn from these points, and they intersect up here. Okay? Let me draw. I'm going to move this up here to this point. I'm going to make this just a little bit bigger, probably about right there. And I'm going to draw sort of part of a circle. Move it down here. Same exact radius for this circle. We're going to go right here. Okay? So this sort of mimics exactly what we see in this drawing of what Eric had constructed. Because what happens if I connect from this intersection straight through here is that this line, let me get rid of this. Let me move this out of the way. Get that circle out of there. It's cutting this exactly in half. Okay, it's cutting it right down the center. This angle is the exact same as this. It's called the angle bisector. So that's what we're looking for, a statement that says that those angles are congruent. Well, ABD, that's this one, should be congruent to CBD. These two, that's this one here. So this is the statement that we want to go with. On this next question, it's following up with the exact same thing that I just did. It's exactly what Eric did up here. Which construction is being created? It is the bisector of a given angle. Bisector of an angle. Not a segment, but an angle. Lastly, down here it says line segment AB is shown in the diagram. Which two sets of construction marks labeled 1, 2, 3, 4 are part of the constructions of the perpendicular bisector? Going back on our page here, that's what I constructed. We're looking for the intersection to happen here and happen right here. Those are the points we need for that. So the ones that do that are 1 and 3. If I connect the lines here, let me draw a line from this point down to this point. It has a perpendicular bisector right there. That's the right angle. So 1 and 3 are the perpendicular bisectors. So that's the constructions. Last, before I close out this video, and then I'm going to go back and work those area questions. Those are mostly for honors. But if you're in standard classes, you can sort of stop after we get through these density questions. Population density, you have your population over the area of the whatever the state is, territory, whatever it is. That's how you calculate it. So in the year 2000, the population of Utah was, let me pull up, it's kind of hard to read on this screen, 2,233,169. So let me rewrite that. 2,233,169. The population in Tennessee was 5,689,283. The area of Utah is 82,168 square miles, and the area of Tennessee is 41,219 square miles. Which statement best compares population density of people per square mile? Well, what we want to do is we want to go ahead and calculate those. So I'm going to say Utah it's 2,233,169 divided by its area, which is 82,168. We'll get a value for that. Let's do Tennessee, which I'm going to do orange for Tennessee, obviously. So TN is going to be, we have 5,689,283 over our area, which is 41,219. Now we just need to grab a calculator and do this division here. 2,233,169 divided by, oh, I didn't write that correct. Hold on. 2,233,169. Okay. Divided by 82,168. All right, we'll round to two places. So I'm going to round this number up. So this is 27.18. So for Utah, 27.18 people per square mile. Now let's do Tennessee. Clear that. We want 5,689,283 divided by 41,219. Okay. So 138.02. We're going to round up that 5 right here. We're going to round that up to, this will be a 0.03. So we have 138.03. So 138.03. Now that we have our population densities calculated, this is people per square mile. Okay. It says the density of Tennessee is about 2 times the density of Utah. Well, not really. If we doubled this, that's not even 60. So this isn't a true statement. The density of Utah is about 2 times the density of Tennessee. No, this is smaller. Okay. The density of Tennessee is about 2.5 times the density of Utah. And the density of Tennessee is about 5 times. Well, let's actually divide them. So if I take this density, divide it by the 27.18, we get about 5. So this is actually the best choice right here, D. So that's the one that we want to pick. Lastly, find the population density of Smyrna. So we'll do Smyrna. We'll use purple for that. We're going to do 40,000. So this is for Smyrna. 40,946 over 22.97. So that's the total square miles of Smyrna. So this won't be a huge number. Well, maybe it will be. This is going to be 40,946 divided by 22.97. Actually, this is a gigantic number. Let me make sure I did that correct. Hold on. So 40,946 divided by 22.97. Okay. That is a very crowded population density. I think maybe this number needs to be changed for reality. But for the example of the question, we'll do 1782. We'll round this up to 59. So 1782.59 people per square mile. I think this area should go up, but we can fact check that later. All right, anyway, if you are in a standard class, this is where you can stop. But if your teacher said that you're going to do the area questions like these, then you should probably watch. but I know for Mr. Wood's classes we're not doing these. But we'll go ahead and get started working through these. The area formulas that we're going to need for these questions, first off we have triangles. The area of a triangle is 1/2 base times height. And then we'll need parallelograms and circles. We got two more shapes. So we'll say parallelogram is base times height, and then a circle is pi r squared. So those are the formulas that are important to remember here. The first thing we want the shaded region. So to get the shaded region, I want to find the triangle's area first. The triangle is going to be 1/2 times base times height. Well, the base on this one is going to be 40. And the height will be this altitude here, which we're going to say, which is going to be 27. So let's go ahead and multiply that. We'll get a decimal very likely. So, oops. We're going to do 0.5 times 40 times 27. We get 540 kilometers squared. Then I want the circle, which is pi times r. Well, this right here is the diameter, which is 12. So I actually want this, which is going to be half of that, 6 kilometers. So r will be 6 squared. So let's do that. I'm going to need this calculator for this. Let me shift this over here. Oops. And we will, oops. We'll just make this, do this calculation here. So pi is going to be right here. I want to multiply that by 6 squared. I'm going to round, actually I'll just keep that whole number. So that's 113.097. Now to get the area of the shaded region, I need to take the area of the triangle and subtract the circle from it. So this is 540 minus 113.097. So on the Inspire, I'm going to do that. This is 540 minus, I'm going to go up here and just copy this. That gives us our answer. The area is 426,903. And these are all in square kilometers per area. It's a square dimension. All right, so there's that first one. All right, next. All right, so here we have a very irregular shape. What helps with this question is to put it into an overall sort of rectangle and then subtract away the blank spaces to get it. So there's a lot of different ways that you could go about doing this, but this is what I want to do. I want to draw a line that goes up here, okay, and a line that goes here. And we're going to assume that this area, change the green to black, this is going to have that same width of 15. This is going to have the same length. This will be a right angle. This is going to be the difference between these. So if we think about this, 26 minus 14, this whole thing should add up to 26. So if I take 26, take away 14, that means that this area plus this area should equal 12. So this is going to be 6, and this will also be 6 as well. When all this is added together, we are going to get our full shape. So to find just the gray part, all I want to do is I'm going to find the area of this whole shape first. Let me actually outline that in purple. So I want to find this entire area first. So that area of that rectangle or parallelogram is going to be area is going to be 26 times 15. Again, your teacher may work this different, but as long as you break it into familiar shapes and subtract the appropriate areas, it will work. You do multiply by 15. So that whole area is 390. So the whole thing is 390. Now I want to take away each one of these shapes here. I want to subtract this, and subtract this from this. We can see here that these two shapes are actually the exact same shape. And there's several ways to think about this. But if I were to draw, let me draw this in blue. If I were to take this shape right here, oops, make it blue, and this shape here, you can see that they're the same. And if I were to redraw them in the shape of a, let's do this. Let me draw that like this. I could rearrange them such that they looked like this. And we would have those dimensions of 6 and 15. So I know that the combined area for these is going to be 6 times 15. So let's do that. So 6 times 15. That's 90. So the area of that shape is 90. That's inches squared. Dividing that in half, which would be each one of these, so divided by 2, gives us 45. So I know that this is 45 and 45 and 45. We're going to take those away from this 390. Now we need the big shape. I'm going to do this one in orange. So from here to here is the height of this triangle here, the one that I put the X in. If this is 6 inches, that means that this one is 15 minus 6, so this is 9. So the height is 9. Using the area of a triangle, and let me draw this one as green. So this overall triangle area, oops, let me change this to green. So area of a triangle is 1/2 base times height. So we get 1/2 times base, which is 26. That's this 26 here, the whole base of it, times the height, which is 9. So let's see what that calculates to. We're going to do 1/2 is 0.5 times 26 times 9. So 117. All right, so I need to subtract from this overall shape the two areas here, which add up to 90. So I'm going to say minus 90. Then I'm going to take away the 117. And we get our final area. So let's start with 390 minus 90 minus 117. So 183 is the shape of our gray area. Let me make sure that that's in inches squared. All these should have those units with them. There it is. So we have those areas calculated and figured out. A pretty fun problem just to think about the different areas within common shapes that we know. We have 3 more questions that we're going to look at. This one here, we have 2 circles. And the first thing that I want to do is we're going to find the area of, I'm going to color these. We'll call this the, well, it's going to be kind of hard to draw that, but we have the inner circle and the overall outer circle. And I'm just trying to find the gray area of this. So the first thing I need the radius here. And then I also need to know the radius of the overall shape itself. Okay, that's what I want. That's going to be helpful. So to do that, this radius here should be, or this blue one here, should be half of this 21, because this 21 is actually the whole diameter of this. If I move this line over, half of that 21 should be my radius. So half of 21 is 10.5. Okay. Now I know that the distance from here to here will be this green line, that radius. Well, that's 10.5 minus this 3.5, which is going to get us 7. So I need to find the area of the blue circle, and I need to subtract it by the area of the green circle. Okay. For these, we're using pi r squared for both. So that should make sense. The big circle minus the white area, the white circle here, the inner circle, will give me the gray area that remains. Let's go ahead and do that. So this is pi times r. The radius of the blue is 10.5 squared. And then for this one, it is pi 7 squared. And we'll go ahead and get these calculated. So let me pull up this. So we're going to do pi times, we'll start with 7 squared. That gets me 153 point, we'll round, actually no, I'll just write all 398, or 938. That is meters squared. Let's do the blue one. So this is pi times 10.5 squared. So 346.361. Now I just need to subtract these to get my overall area of the gray region. So area equals 346.361 minus 153.938. And that's going to go here. I don't want to forget my units. Grab my calculator. Let's just copy this area, subtract this area. We get 192.423. So 192.423 meters squared. There's our answer. Cool. Next, we have, if we can continue this shape, let's connect from here to here. We're going to assume that this is a parallelogram that is created. Okay, these two lines are going to make a parallelogram, and we see area for a parallelogram, which I'm going to continue all the way around this. So that area is equal to just base times height. So we see that already. The base is 23.8 times the height of 15. I'll just put that in parentheses. So I know I need that. Now the gray region is that area, the blue one, taking away this triangle here. So let's give the triangle a color. Let's do green. So from here to here to here to here. And so the area of a triangle is 1/2 base times height. So 1/2 times the base of this triangle, well, that's this length here. This is actually the base. The base always has the height intersecting with it. This 21 is going to be our height because it's the altitude. It has the right angle. And this is going to be the base. So 23.8 times the height of 21. So let's go ahead and calculate these areas. I'll do that on this calculator this time. So 0.5 times 23.8 times 21. So 249.9. This is feet squared, square feet. Let's do the other one. So this is going to be 23.8 times 15. We get 357. To get our overall area, just the gray shaded region, it's going to be the difference between these. We're going to take 357, subtract 249.9 to get our overall area. Keep forgetting my units. Okay, so let's do this. 357 take away 249.9. So, oh, I multiplied. Okay, try that again. 357 take away 249.9. So 107.1 feet squared. All right, last question, and we'll be done with this review, and you'll be ready for your test. So we have a square that's inscribed in a circle. The main thing that we want to find is the radius of this circle. Okay, so if I were to draw a diagonal from here through that point to here, we know that this, let me move that up. This is a right triangle. So if I were to draw this right triangle, this is 8, and this is my diameter here. This would be C. Since it's a square, we also know that this is 8 right here. Okay, so this is 8, this is 8, and we can find the diameter of this circle by using Pythagorean Theorem. So this is going to be, it's a squared plus b squared equals c squared. Okay, our goal is to find the area of this whole circle so we can get the shaded regions only. So this is 8 squared plus 8 squared equals c squared. That's 64 plus 64, which equals c squared. That's 128 equals c squared. And we're going to square root both sides here. So this is square root of 128 equals c. I do want to go ahead and simplify this. I don't want to put it into a decimal yet, but if I were to simplify it, I could rewrite it as square root of 2 times 64. Break that apart into square root of 2 times square root of 64. We know the square root of 64 is 8, so actually this is 8 times the square root of 2. So that's actually going to be this diameter. 8 square root of 2 is this whole diameter. I'm interested in the radius. So the radius is going to be half of that distance. Let's go this way to get our radius. Well, if I divide this in 2 to get the radius, we get, so I'm going to say r is equal to 4 square root of 2, because all that does is divide the 8. So this purple is 4 square root of 2. What I need to do is I need to find the area of the square and the area of the circle. So this is my square. And we'll say that the circle will be purple. So the area of the circle equals pi. So this is pi r squared. R is 4 square root 2. We're raising that to the second power. Then for our square, that's going to equal 8 squared. 8 times 8, but 8 squared, just to get our area of a square, that's 64. And we just need to go back and calculate this one. So let me pull up the Inspire one more time. We want pi times, I'm going to use parentheses for this one. We want 4 square root 2. Close that, close the parentheses and raise that to the second power. So that's going to be an area of our circle. 100.531. This is in centimeters squared. This is centimeters squared. To get our overall area, it's going to be, well, I want to take the circle and just take away the square area. So this is going to be the 100.531, take away the 64 to give us our overall area for this. So let's do that. 100.531 subtract 64. So the area of that gray region is 36.531. let me move this down. Get that out of the way. So 36.531. Centimeters squared. And that's going to be our answer for this shaded region. That's going to conclude this video. We've worked through all the questions except just those two with the parallelogram and rhombus, but I trust that you can get those on your own. Good luck on the upcoming test.